Hello, welcome to the Notebook of Solutions. Today we will find the maximum and minimum value of a function using successive differentiation. The given function is f of x equals to x to the power 4 plus 2x cube minus 3x square minus 4x plus 4. So what is successive differentiation? Successive differentiation involves differentiating a function multiple times to find important points such as critical points and to determine whether the function has a maximum or minimum value. It helps us to understand the behavior of the function at different points. So, at first we will differentiate the function once, which is known as the first derivative or f of x. To determine the first derivative, we have to differentiate the given function once. So, here we have written d dx of f of x. So, in the place of f of x, we will replace it by the function, and we know if we differentiate x to the power 4, it gives us 4x cube. If we differentiate 2x cube, it gives us 6x square. That's how we get our first derivative. Now, we set the first derivative equals to 0 to find the critical points. If we solve this equation, it gives us critical points. What is critical point? It is a point of the function where the derivative is 0 or undefined. These points tell us where the function may have a maximum, minimum, or inflection point. Now, if we solve the first derivative, we get x equals to minus 2, x equals to 1, and x equals to minus half. These are the three critical points of the given function. Now, we will find the second derivative. For that, we have to differentiate the first derivative once to get the second derivative. So, we already determined the first derivative. We have to differentiate it. We know how to differentiate, and we will get the second derivative, which is 12x squared plus 12x minus 6. Now, we already determined the critical points. Now we will put these critical points in the second derivative to find whether the maximum or minimum value of this function exists or not. So, using this critical point, we have to substitute them into the second derivative, and if the second derivative is less than 0 at that critical point, it means the function has a maximum value. And if the second derivative is greater than 0, it means the function has minimum value at that point. So let me do that. So the critical points were 1, minus 2, and minus half. Let us put these critical points in the second derivative. So if x equals to 1, the second derivative gives us the value of 18, which is greater than 0. So we can say that minimum value exists at point x equals to 1. For x equals to minus 2, the second derivative gives us the value of 18 as well. So it is also greater than 0. So we can say minimum value exists at x equals to minus 2. Now, if x equals to minus half, the second derivative gives us minus 9, which is less than 0. So we can say maximum value exists at x equals to minus half. Now, we have to determine the value of maximum value and minimum value. So, we already know for which critical points we will get the maximum value and for which critical points we will get the minimum value. Now we have to put these values in the given function, which is f of x, which will give us the maximum and minimum value. Now let us put the critical point minus half in the given function f of x. So this was the f of x. Let us put minus half in this function. This gives us the value of 81 divided by 16. This is the maximum value of our given function. So for the minimum value, we already determined that minimum value exists for x equals to 1 and x equals to minus 2. So put x equals to 1 in the given function and put x equals to minus 2 in the given function. Both of these gives you the value 0. So we can say that the minimum value of this function is 0 and the maximum value is 81 divided by 16. So that's how we can determine the maximum and minimum value of a function using successive differentiation.